First off, a piece of good news, at least to us maintainers, JUnit 5 has been released finally after 2 years in the making on September 10th this year. So it's actually now a final release. It's no longer milestones and release candidates. It's something you can actually use in your production projects. So before I explain this picture, I would like to know, can you give me a quick show of hands? Who has seen a picture like this or similar before about JUnit 5? Okay, not too many people. Yeah, so if you haven't, in the abstract for this talk, there's actually a link in the top here that gives a more brief introduction into JUnit 5, and I recommend that in case you're interested. It's from the Heisenberg conference here in St. Petersburg a couple months ago. So JUnit 5 no longer is just one artifact. It's actually multiple modules, and they fall into 3 categories. There is Vintage, which kind of is the old JUnit 4, and there's Jupyter, which is the new way to write tests, and there's the platform. And all those 3 things together, that is JUnit 5. Yeah? So they have different group IDs in Maven, for example. And this talk will really only focus on the Jupyter part, so the green box in this picture, which is what you will use when you write new tests using JUnit. And if you look at it more closely, inside the Jupyter box, there's actually 2 artifacts hidden behind that, the Jupyter API and the Jupyter engine. And the Jupyter engine is something that most people will never really have to deal with, maybe besides adding a dependency to it in test runtime scope. But the Jupyter API module or artifact is really important. It contains the programming model to write tests, and also the extension model for extension authors. So if you're a person that not only writes unit tests for production code, but also provides extensions to make his life easier, or maybe extensions for other people to use. If you're a library like Mockito, for example, you will be doing that. There's also an extension model inside it. And what do I mean by that? Well, the programming model is what you use to write tests. So this is a simple test class with 1 method in it. It's annotated with test, and it has a display name annotation on it. So those are part of the programming model. And also there's extend with, which ties into the extension model. It's the simplest way to actually register an extension to be used for just this one method. So that would be the programming model. Of course, there's lots of different annotations. There's also the assertions class, that's your actually specify assertions that should be checked. That's also part of the programming model of JUnit Jupyter. The extension model, on the other hand, all the classes that you need there are in the extension package, so org JUnit Jupyter API extension. And in this case, we implement 2 interfaces in our custom extension here, the before each callback and the after each callback. And each interface has 1 method, so we have to implement 2 methods in order to implement our extension. And there are multiple interfaces you can choose from, and we will see a couple of those in the remaining talk. How do you register extensions? We've seen one way, so you can use extend with to register an extension. It can be used on the test class level or on the test method level. It can also be used as a meta annotation, so you can define your own annotation and put the extend with annotation on the definition of your custom annotation, and then JUnit will also find it. So that's a concept you might know from Spring, for example. If you haven't seen it in JUnit 5 so far, we also support that. But there's also a global way. So instead of changing every test class to register extension, you may want to register it once and for all tests. That's also supported. It's opt-in, so I have to explicitly enable it, either using a system property or a properties file, and it uses the service loader API. And we will actually see that in the first demo that will be about conditional test execution. So let me show you the example. All right, so here we have a test. It has 2 test methods, which is annotated with test here. So it doesn't really matter what they do for now. What matters is that you often have the case that you have some kind of integration testing, and maybe you want to check your servers in a different environment if they're still working as they're supposed to do. So you have some kind of active monitoring. You check that the API still works. And so you would like to annotate your test with an environment they should be enabled for. For example, maybe there's a test that does some deletion, and you better not want to run that in production. So you could say, okay, I only want this test here to be enabled for dev and QA, right? And that's actually not something that comes with JUnit. That's something you can define on your own, given your own semantics. So in this case, I have defined a local annotation here, which is called environment. And it needs retention runtime, so JUnit can actually find it at runtime. And it is annotated itself with extend with. So this is a meta annotation in this case. And if you look at the annotation, it says, well, you need to give me an extension, but extension is just a marker interface. So there's actually nothing in here. You need to pick one or more actual extension points, extension interfaces that you implement. So let me show you the example that I've prepared here. So one of these interfaces is execution condition. So when I go there, you see, okay, it extends extension, and it has one method, evaluate execution condition. This method gets an extension context. For now, you can think of the extension context as a representation of the current location in the test tree. So for example, a test method has an extension context, a test class has an extension context. And from that extension context, you can get access to things like the display name of the test, or which tags it has, which test method it is for, or which test class, all kinds of things. So in this really simple example, we're just going to take a look at the some system property called environment here. And that's going to be our active environment. So that's the way we actually trigger that. And if there's no active environment, actually we want to make sure that the test is disabled. Otherwise, if there is one, we're going to read the annotation here, the environment annotation, and we're going to, if it's present, we're going to get the enabled for field from it, which is just the string array. And if it's there, we're going to add it to the enabled environments. We're going to return those. And then we have our set of strings, and we're just going to check, okay, if the enabled environment contains our active environment, we can say, okay, enabled. And this method returns a condition evaluation result, which is basically a Boolean with a reason. Yeah? So it's either enabled or disabled, and you have to provide a reason for that. So in case it's disabled, maybe the user wants to know why it's disabled. So if I actually run this test, let me show you that. I haven't defined a system property yet, so let's do that. Let's say, okay, I want to run this in dev. So it should run, because we have said dev should run, right? Oh, I actually need to run the right test, sorry. That was the wrong one. Okay, again. I just ran a different test for a later example. Yeah, so now let's run the right test. Okay, now as you can see, add was run, and subtract also, which we're not interested in yet, but add was run. So let's change that. So if I say, okay, I want to run this against live now, then the test will be skipped. And as you can see, IntelliJ displays the reason that we've given here. Active environment is not enabled. So you can write your own conditions when tests should be executed and when they should be skipped. And that's one of the extension points that we provide. All right. Yeah, I talked a little bit about extension context. I want to give you a little more detail now. So as I said, it represents the current node in the test tree that you get in the IDE, right? So it could be a test method, a test class, in the simplest cases. And it provides you with access, for example, that you can use in an execution condition implementation to reason about should this test run, should this test be skipped, and so on. But actually, it's a tree. So each extension context can get access to its parent, which is sometimes also useful. So if you're in a test method, like, I don't know, test2 here, you can actually get the parent and look at the parent. Is that this test class or that test class? So that's sometimes useful. And there's even a root extension context, which is not a test class or a test method. It's just a JUnit Jupyter root node. So for this test engine, also has a root node, and you can use that to look at some information for it. So we have seen how we can implement custom logic to determine whether a test class or method should be skipped. We have not yet seen how to use global extension registration. I will show you that now. So the second test here, I have intentionally commented out this annotation here, right? So with this environment condition, it would be nice, it would be more safe if we could just skip all the tests that don't have an annotation, because maybe someone just forgot to add it, and then this test would run against some live environment or something, and we don't want to have that really. So as I said, there is global extension registration, and the way it works is using service loader. So first of all, there's a properties file here that you can use. As I said, it's an opt-in feature, so you actually need to set this property. Extensions auto detection enabled to true, which will tell JUnit, okay, I should look for extensions that want to be automatically enabled. I should detect those. That's the first step. And you could also specify that as a system property. And the second step is then to use the standard service loader mechanism that has been around since, I think, Java 6, where you have in meta-inf services, you have a file that's called like the fully qualified name of the interface that you actually want to implement. And inside, you list all the implementation classes that you want to register for it. So in this case, it's also just our simple extension here, and we can list that. And now if we run this test again, you will see that subtract is now also skipped, because subtract doesn't have an environment annotation on it. See, it's commented out. I can even delete it, and it will still be skipped. So this is a way to register extensions globally, so we don't have to change the code for it. There's also a way to deactivate conditions. So in case you do want to run all the tests and don't evaluate any conditions, whether they should run, there's also another property that you can set in this properties file, or using a system property to deactivate conditions. And you can give class names that you want to deactivate, or you can just say star, I want to deactivate everything. And when you run this again, you will see that both tests are running. So you can add extensions, you can influence the behavior using this properties file, and you can actually check that in, so you not have to rely on system properties. All right, so let me revert that for now. So we have now seen how to use global extension registration, and we have seen how we can deactivate a condition or all conditions without changing the code, using system properties or even this properties file. That was the first example. Another thing that you can do with extensions is to create a reusable test setup in teardown, or a test fixture, as some people like to call that. So what you often have, you have tests that kind of rely on the same setup, and you want to make sure it's cleaned up in the end, right? And the traditional way to do this is to create a superclass for all your tests and do the setup there. But as we all know, you can only have one superclass, right? So that doesn't really scale. And so there are better ways to do it. And JUnit 4 had rules, and JUnit 5 has something that also provides you with a nice way to do it. So let me show you how. Okay, so for my example, I have picked starting and stopping a Docker container as my test setup in teardown. Of course, it could be anything. It could be starting a server and stopping it again, or whatever you want. But in this example, I have added a new container annotation here that lets you specify the Docker container that you want to start before the test. So you need to give it the image name, which in our case is MariaDB, so the open source MySQL fork. And you can specify the ports that you want to have mapped and maybe some environment variables like here, like the MySQL root password and the database to use. And once you have that, the expectation of the test author is, okay, this container should now be available for my test, right? In the way I have set it up, so I can actually connect to this database. And, well, the exact code is not really that important, so we create a data source to this database using this port, using this database name, using this password that we set. And we have to wait a bit for it to be available, because starting up the Docker container is one thing, but actually MySQL starting up inside the Docker container is a different thing. So you have to wait for that too. And once that is ready, we're just going to return some Fluent JDBC. It's a library that I use here, which makes JDBC a little less painful. And once we have that, we're going to create a table here in our test, and then we're going to execute our code under test, which in this case is also located in the test class. So normally this would be in some production class, obviously, but it only inserts a name into a table. That's what we want to test right now. So that's that. We execute this twice for 2 different names here. And in the end, the test then queries the name from the database again using a simple select statement and checks that the names that it has inserted are actually returned from the select. So it's just for demonstration purposes, it's a pretty simple test. And to show you that I'm not cheating at all, I can show you that I currently don't have any Docker containers running, right? And I can't really connect to any database here locally, because there's nothing running. And let's now add a breakpoint here and start this test in debug mode. So of course it takes a couple seconds for this Docker container to start. Okay, now we're at the breakpoint. So now we should have a Docker container running, and we do. And it's actually this one, and the port mapping is also there, as you can see. And I should now be able to connect to it. And there's already the table. The example table is pretty small right now. It's not really that important. And now we can execute our code under test and check that actually 2 rows are here, so they are. And yeah, I guess then now it should be successful, right? Let's finish it. Let's keep it running, finish it. Okay, it's done now. And we can check that the Docker container has now been stopped. It even has been removed. Nothing is running anymore, and the database connection is also gone. Yes, error. Okay. So that's a simple way, a simple reusable way to do that. And while this is a cool feature, it's not yet finished or anything. It's just for demonstration purposes for this presentation. The container annotation itself is where the magic happens. So this annotation is annotated with extend with, and I have written a little Docker extension here. And yeah, it implements 2 extension interfaces before each callback and after each callback. Both come with 1 method each. So the before each callback, what it does basically, it looks for the container annotation, and in case it's present, it will start the container given the arguments from the annotation, like the image, the environment variables, and the ports. And if in case that happened, start container will return a string, which is the container ID, which I will then store. I will talk about this getStore method in a second. For now, just think about it. Okay, I will store it somewhere, the container ID. Why do I need to store it? Well, I need to get it in after each, right? I need to stop it again. So in after each, I will get the container ID, also using the store down here. Yeah, so I'm getting the store, and then from the store, I'm getting the container ID, which happens to be the same key as up here. And if there is a container ID, then I will stop the container again. And the exact implementation of how this start container and stop container works is not that important right now. It uses some Docker Java library, but it could be whatever, right? So this is how it works. And yeah, just have to implement these two callback interfaces, basically. So let me talk about this store for a little bit. So the getStore method is actually a static method I have defined down here. It has the extension context that I'm running on as a parameter. And as you can see, the context has a getStore method that takes a namespace parameter. It's this part here. And basically, you can use that to store stuff that you need to access later in a different callback method. And that's the whole magic. And the store itself basically has a map-like interface, so you can put things into it and you can get things out of it. That's pretty much it. There's a couple of convenience methods to compute something if it's not already present, and things like we know already from map, so it's pretty simple. And I will explain to you why we actually need that in a second. So, as we've seen, methods within an extension need to save and retrieve data, for example, to clean up in the end, right? And extensions are instantiated once by JUnit. So if you, for example, if registered globally, it will only ever have one instance. Now, if each extension would have to find its own way to store data that belongs to a certain test, that would be error-prone at least, right? Think about, we might add execution in parallel in a future release and things like that, and then every extension would have to get it just right. So instead, we provide this store abstraction that should make instance variables in extensions pretty much unnecessary, because you can store things at the right place. Yes, so as I said, map-like interface for extensions. We've seen that. It can be accessed via a namespace. So that enables actually sharing data across different extensions. So if they use the same namespace, they can see each other's data. That's by design. But it makes it a conscious decision. So you have to think about it, which namespace you want to use. So in the simplest case, you can use namespace global. Then it's kind of obvious that it's actually available to anyone who uses global as a namespace. But you can also use something that's very specific to your extension. If you put the extension class into the namespace, for example, or some unique ID for the test identifier, then it's really pretty much unique and no one else should be able to read that, and that's a conscious decision. Moreover, reading from the store actually will follow the hierarchy upwards. So if you want to get some data, maybe the parent extension context already has that data. So you don't need to compute it twice if you need something for the test class, for example. So this is how it looks in a big UML picture. I hope you're not too intimidated by that. So we have a test extension context kind of little tree here with just 3 nodes and on the left. And when you're on the test level down here, you can get the store for a given namespace. And when you ask the store for a value, it will actually check the local store. And if that has the value, it will return that, of course. But if it doesn't, it will follow the hierarchy upwards. So it will follow from C store to B store to A store. And only if that also doesn't have the value, it will return null. Yes. So we've seen how to use store. We have seen that we can use lifecycle callbacks to enable reuse of common setup and teardown code, and that we can implement multiple of these extension interfaces in a single extension. Okay, what else can we do with extensions? The next example will show you how we can resolve test parameters with an extension. So, pretty much the same test now as the container test I just showed, but in this case it's with dynamic ports. So why do we need that? Well, the thing is, if you only have the port once on your host machine, right? So if you want to run multiple tests in parallel and you bind it to the same host port, you will run into problems. So Docker has a nice feature. You can tell Docker, okay, I want to expose this container port here, and Docker will figure out the host port on its own. It will just pick a free one and give you that. And this is actually something that we would like to use in our test. But for that, we need some kind of communication from the extension into the test method. And in this case, we have solved this with a parameter resolver. So as you can see, this test method previously had no parameters. Now it has 2 actually. And I have registered an additional extension here. And this extension will be responsible for resolving the network settings parameter here. And actually, JUnit provides another extension that's registered by default that can resolve test reporter parameters. I will show you what they are useful for in a second. So let's look at this additional extension that I've registered here. So the Docker parameter resolver implements parameter resolver, obviously. It has 2 methods. The supports method is called first to check whether this extension can actually resolve this parameter. In our case, we're just going to check, okay, do we actually have a container ID? So did we start something? And also, is the type that we are asked to resolve network settings? And only if it's true, the resolve parameter method will be called. And we can get our Docker client and we can inspect the container given the ID that we have. And in the response, part of it will be the network settings. And we're just going to return that and resolve it. So basically, this is how it works. All registered parameter resolvers get asked to resolve a parameter, and only one can win. And in that case, this parameter resolver will resolve the network settings, and a different one will resolve the test reporter. And those 2 will be then passed on to connect to database. And we will figure out the MySQL port from the network settings. This is a bit ugly here, but basically we know, okay, we've exactly exposed 1 port, so we can get that 1 port here, just the first one. That's our port. It could be more sophisticated than that, of course. And also we see that the test reporter here is used to publish an entry. So basically you can publish maps, key value pairs, whatever, and those will be added to the reporting that JUnit provides to the test execution listeners. So in case of IntelliJ, when I run this, you will see them in the output here, but it's not actually written to system out. So it will not have the same issues that system out has when you run tests in parallel. Instead, these things are really attached basically to this node in the tree here. So as you can see, the MySQL port is this one. And so 771, when I run it again, it's 772. So Docker really figures out the port that it can use. And yeah, I don't really care about which one that is. Yep, so that's how you can actually resolve parameters. And you can, of course, use that in different ways. So for example, there's a Spring extension that resolves Spring Beans for you. You can think of whatever you want. It's really a general mechanism that the extension model provides. What you can also do is you can inject parameters into test class constructors and before each and after each methods. So the same extension point is called for those, and you can then either inject the same things there or something different. That's up to your extension. Okay, next example is providing arguments for parameterized tests. So as I'm sure not everyone here has already seen JUnit Jupyter parameterized tests, I will first start by showing you an example, or a couple examples actually, of how to do that. So let me show you. So the simplest one here is this one up here. Instead of annotating the method with test, we write parameterized test. And then we have to specify at least one of these source annotations. So in the simplest case, I just used the value source annotation, which you can give primitive types, primitive literals, or string literals. And in this case, I use strings. So foo and bar will be the arguments. So when I run this, you can see that there are actually, beneath the test method, there are 2 additional nodes, one for foo and one for bar. And these will be the ones, were the ones that were executed. And you can do even more than that. You can, for example, use comma-separated values. So I have two strings here. Each one has a comma in it, so they both are comma-separated values. So think of it as a line in a CSV file. And the method here actually has two arguments, a string and an int. So foo will be the string and bar, right? And 42 and 23 will be the ints. And JUnit will do this implicit conversion for you. So you can run those and we'll see, okay, foo. And what also I have done here is I've customized the display name here for each of these invocations. So that's also something that you can do, but you don't have to. A third one, there are actually more than three, but a third one is method source, which lets you specify a method to be called. So it's a bit like a data provider in TestNG. It's a method, and IntelliJ also has support for it. That needs to return, well, it depends on the method signature. In this case, it's taking a person, not just some strings or ints or primitive types or anything, but a real object, a real domain object. And in this case, a method source is quite nice, so we can just call the person constructor here twice and return a stream. This could also be a collection or a list or whatever. And when we run this, you will see that it's called with foo and 42 once and bar and 23 once. So that's kind of how parameterized test works. And each of these source annotations basically is implemented in the same way. And you can also do this on your own. So for example, here in the next test, I have a JSON source annotation. It takes a file name of a JSON file. So when I open that, basically it will contain a list of JSON objects, and this represents a person, and this is another person. So I can then read those from the JSON file. So that's the expectation. When I run this, you will see it works. Yeah, so in the same way, pretty much like the method source worked. But in this case, it's not something that comes with JUnit. It's something that I've implemented here in the demo project as an extension. It's a custom annotation. It has, in this case, just one string value. And it's annotated with argument source. And the argument source, you have to specify a arguments provider that you want to use. In this case, I've implemented a JSON arguments provider here. Basically, the interface has one method, provide arguments, given an extension context again, and it needs to return a stream of arguments. So this can be a lazy stream. It can be the first argument will be evaluated first, then the next one, and so on. And also, I've implemented annotation consumer here, which makes it easy for me to actually consume this annotation. It's just one accept method that I say, okay, I want a JSON source annotation, and I get it injected here so I can initialize my state here, which in this case is just the resource I need to read. And in the implementation then, I read the resource as a stream and read the values from it. In this case, I used Jackson here to read the JSON, but you could use whatever you want, of course, and it returns a stream of these values, in this case, person objects. And yeah, it figures that out from the parameter type of the method, actually. So this is how it works. It's pretty much just this one annotation here and this one argument provider. And of course, you could do this with, I don't know, a database or whatever, wherever you want to read the values from. You could support that by implementing such an annotation and an arguments provider. All right, so last but not least, test templates. So a usual test is one test method that is executed once. And test templates are a bit different. So a test template method is actually a method that is executed like a template multiple times in different contexts. And what those contexts are is again up to an extension. So this is by far the most complicated example. So bear with me for a minute. Yes, so this is the example. I have this class called property tests. And for that, I need to explain a bit what property is. So traditional unit tests are example-based tests. So you write one set of input parameters and you expect one output, and you check that output for your expected value. That's basically how a unit test works, a normal unit test. Property-based testing is a bit different. In property-based testing, you don't specify one example. You think about more general properties that your code should satisfy, should fulfill. And here's an example. So given a list of strings and an arbitrary string, if the list has this previous size and I add the new item to the list, well, then the new size should be the previous size plus 1, right? So that's kind of written as a property, not just with one list and one string, but for any strings. So it's kind of a more abstract specification, if you want. And this is not something, again, that JUnit Jupyter provides, but I have defined that here locally. So I have this property annotation that I've defined here, and it's annotated with test template. So this kind of marks this method as a test template where the property annotation is on. And also it specifies an extension to be registered. And if you have a test template, you also have to have a test template invocation context provider, which is a rather long name. But that's what it does. It specifies or it provides invocation contexts for test templates. It has two methods. It looks a bit like the parameter resolver. The first one is called to check whether this extension, which could be registered globally again, supports the test template. And in this case, we're just going to check, okay, does it have the property annotation on it? In case it does, we call the provide test template invocation contexts method. So this one here. And this is where some magic happens. So we find the property annotation, which we know is there. Otherwise, we can throw an exception. And we get some random generator. We determine how often do we want to check this property. So usually how property-based testing works is you generate a set of random arguments up to a certain number, and then you test it. So you can now never prove that this property is true, but you can try to find counterexamples for it. And usually you do this by specifying a maximum number of invocations that you try. And in this case, we're going to use 100 by default. And then basically we use stream generate here to generate an infinite stream of invocation contexts, which we will then limit to the number of invocations in the end. So it will actually finish at some point. And for each of these, we'll generate or create an invocation context. So the first step for this invocation context is we generate some random arguments. So this right now is implemented really simplistic here in my example. It only supports lists and strings, and that's it. But this could, of course, be implemented in a better way. And so once we have these arguments, I'm just going to look at the test method, generate arguments. We can use them, the string representation of it, to return a custom display name for this one invocation of our test template method. And more importantly, the test template invocation context also can provide additional extensions that should be registered just for this one invocation. And in our example here, we will have a parameter resolver. This one's actually pretty simple. It will always support all parameters, and it will just return the random parameter we just generated for the given index. So basically, really simple implementation of parameter resolver here. And also we have an after each callback here that is a bit more complicated. It actually checks whether the context has an execution exception. So in case the test failed, it will have an execution exception. And then it checks, okay, if it's not just aborted, but really failed, then it will set some atomic boolean to false. And this will then be used up here to check, okay, do I need to stop? So the intention is to stop after we found the first counterexample. It's not to go on and generate more random inputs. So let me run this for you. Who thinks it will be green? Who thinks it will be red? One, okay. At least someone raised his hand. Thanks. Okay, so I run it and it's red. So congratulations, you were right. Why is that? Well, as you can see, the first one, element added, size increases. The first property here, that one's green. We didn't find a counterexample. But for this one, actually, we found a counterexample pretty quickly. So removing an element decreases list size. Well, that is true, but only if the element contains an element, if the list actually contains an item. If it's the empty list, like in this counterexample here, of course it will fail. So we can use an assumption, which is something to mark the test as aborted in JUnit Jupyter. And just say, okay, we're just going to assume that items is empty is false. So that's kind of the precondition for this property. And once we do that, we can run it again, and this time it will be green. You can see that we actually generated the empty list quite often. So this simplistic little property-based testing thing I wrote here is not perfect yet, but it didn't find a counterexample for this property that I've written here. So of course that's not a perfect property-based testing framework yet, but you can see these test templates are actually kind of useful, and we've actually implemented parameterized tests with them and repeated tests. So this is not just an academic example. Yes, so we've seen how we can execute a test multiple times in different contexts. So these contexts could be different parameters, as in our case. It could also be something different. For example, I don't know, different setup, different database, or something like this. And we've seen how we can implement a test invocation context provider, which is by far the most complex of these extension points. There are a couple of support classes I haven't yet really mentioned, so maybe one or the other has seen annotation support in the code examples that I've shown. So the common support package contains annotation support and reflection support. Annotation support can be used to scan for custom annotations, and it provides the whole implementation of this meta annotation stuff. So that's not something that is provided by the JDK. We actually had to implement this on our own. So if you want to use that as well and use it in using the same semantics that JUnit Jupyter uses, then use annotation support. And also there is reflection support. So if you want to implement your own test engine, you could use reflection support for class path scanning. So we expose that for you. But it can also be used just to find a method for a given class, or invoke this method, creating a new instance, and just little convenience methods that we also use throughout the JUnit code base. Summing up, yeah, JUnit Jupyter is really extensible. Was one of the main design goals for this new extension model. There are a lot of extension points that you can choose from. And the good news is that we will add even more extension points in the future. So if something is missing, please let us know. And first of all, we will try to figure out a solution for you together. And if there's no solution and we really need a new extension point for it, then we will add it. That's pretty much what we want to do. And the power really comes from combining multiple of these extension points in a single extension. So here are a couple of resources to get you started. So there's the user guide. It's not yet really written for extension authors. It's more written for test authors, I would think. So it tells you how to write tests, how to run them in different build tools, IDEs and stuff. But there's also a sample project that shows you how to write an extension. In this case, it's a Mockito extension. Actually, the Mockito project is starting to write their own extension now. So at some point, that concrete example might become obsolete. But it shows you what you need to write such an extension. And of course, there's Javadoc if you want to know more details about how some API works. The Javadoc is quite good. Of course, the source code is also available. And what we want from you, if you try it, is feedback. So there's Stack Overflow. There's a tag JUnit 5 closely monitor. So whenever there's a new question, we try to answer that. And of course, there's GitHub issues. So if you find a bug or have a question that no one on Stack Overflow can answer and we didn't answer or something, please don't hesitate to open an issue. And if there's really too much hassle, then there's also Twitter. We have a Twitter account, so you can send us a tweet, and we'll try to reply to that as well as soon as we can. So that is pretty much it from me. The example code that I've shown is on GitHub, so you can look into all the methods I haven't expanded right now on your own if you want. And you can also send me questions about them either now or when I'm back at home via GitHub. Thank you.
Thank you, Marc. Questions?
Thank you for a perfect presentation. And I have maybe some kind of stupid question for you. But have you ever planned to publish your Docker extension as a standard way to use this? Because in where we realized exactly the same thing with JUnit 4, there were a lot of ugly boilerplate code, and it will be very good to have this extension in standard package or in Maven and someone else.
Yeah, so the idea is right now that we try to keep the JUnit core itself small, and if there's an extension, it should rather go into a separate project. There is an effort that's called JUnit Pioneer, which is actually not from the core team, but they wanted to provide somehow some umbrella project. Well, they can host extensions and do releases for them on GitHub, but it's not really started yet so far. So we're in a pretty early state. And there actually is a guy, I think, from France who wrote a Docker extension as well. So yeah, there should be one repository, one artifact that you can use at some point. But we don't plan to provide that as part of the core JUnit framework.
Okay, thank you.
Good day, thank you for your speech. From what I've seen, correct me if I'm wrong, but in all your examples, the model of test execution was pretty same. I mean, there always is a class representing some test suite, which methods are certain test cases. Mm-hmm. Can we override this model with extensions? I mean, for example, not each method. What I mean is define a way how JUnit discovers certain test cases. Okay. Yeah, JUnit has its own notion of what a test looks like. Yes, and it's supposed to be a test method. And it supports some other things like dynamic tests. There's a test factory method and test templates. But that's what JUnit Jupyter thinks that's a test. If you want to have some different way to write tests, then you will have to write your own test engine. And that can also run on the JUnit platform. So, and it can then also run in all the IDEs and build tools that support the JUnit platform. So for example, we have tools for Gradle, for Maven, for the console that support arbitrary test engines. So if you want to have a different way to write your tests, I don't know what it might look like, then the general answer would be you have to write your own test engine. Well, but you showed in your example of test templates a way to define some sort of set of tests, executions. Mm-hmm. And everything was good, but it would be better to have a way in this test template invocation context to define a way how to run this test. Mm-hmm. And it would be enough to declare this model, this new model. Isn't it possible?
Yeah, well, maybe I can show you dynamic tests after this presentation.
Okay.
And then that might be an answer, because there you can write a method and then you can return something from it.
Thank you.
Hello. The question will be about parallel tests, execution, and about ordering, that's a part of previous question. Is it possible to somehow, how the parallel running will be affected with new extension structure, with new extensions functionality, and how the order previous functionality will be affected?
So right now, Jupyter does not provide a way to run tests in parallel at all. So you can use, the only way I know of is you could use Maven and use forked VMs to fork on the class level. But we plan to add that feature in a future release. So there's still an issue open, and we have some ideas how to implement it, but it's not done yet. And the same holds true for the ordering. So Jupyter does not yet provide a way to order tests, but this will, at that point, also be an extension somehow. Yeah, but it's not done yet.
Еще вопросы, пожалуйста.
There's one here? Maybe?
Hey, I'm here. So I also have a question about ordering. Maybe there exists some way to organize some kind of chained tests. An example, I'm turning on some environment, for example, Docker container, and after that I'm going to execute one by one chain of tests, and if one of them go into fail, make running turn down method. Maybe it could be implemented.
Yes. So yeah, there's actually a feature that we call scenario tests that isn't yet implemented. That we intend for those kind of things where you have a test class and you want to kind of build upon the result of the first test method in the second test method. So I don't know, for example, if you have some UI test, you want to log in first, and then after you logged in, you want to check something and things like that. It's not yet implemented, I'm afraid. Also, there is a issue open for having a callback that is called just once for the whole test execution before and after. So maybe for starting a server or something. That's also something that will probably be added in a future release. And yeah, so, but you can always, there's these callbacks that I showed now. So if you just want to do something before the class and after the class, there's also it's called a before all callback and after all callback. So you can also do that on the class level. That's what I just did on the test level. So if it's just in one test class, that should work.
Thank you. Еще, пожалуйста, здесь рука, по-моему, была.
Hi.
Hey.
Does JUnit 5 work with Java 9?
Yes, it does. And we actually, in the next release, 5.1, we will add support also for module path scanning. So right now, we support class path scanning. If you want to work with modules, we support, so we do already ship manifest entries for module names. So we're kind of Java 9 ready. And in 5.1, we'll actually ship a multi-release jar file to support this module path scanning. And you can say, okay, I want to run all my tests in this module. That is something that's supported then in 5.1. But right now, the current version already works in Java 9. So if just Java 9 happens to be a runtime and you don't need module path or module path scanning or anything, then it already works.
Okay, thanks.
Hello, just ask, maybe you know about our Killian project.
Yes.
Have you any communication? Because what I see is very similar with our Killian project, like containers, extension points. Have you any communication with these guys?
Well, the idea is that we have enough extension points that they can just use those without having to write their own test engine or anything. But we haven't been in close contact with them yet. So I would expect that to happen in the next few months. If they want to make the move to JUnit 5, then yeah, we're here to contact, let them know. We have enough on our plate not to be reaching out to everyone right now, but yeah, sure, it should be supported at some point. There might be an extension point that is missing yet that they need, but I'm not totally sure.